Hi everyone, thank you very much for watching this live event, Spring in Winter from many publications. I'm Laurențiu Spilcă, the author of Spring Security in Action and Spring Quickly. Well, Spring Security in Action is actually a book I wrote, and Spring Quickly is a book I'm currently writing, but it's definitely there are definitely a couple of books you need to read. And if you want to buy a hard copy, they are very useful. You see, I actually use one for my mouse pad, so it's really useful. You can buy it for different things you want to do, like rising up your monitor, because hell, who is actually reading books anymore? So you just take it to use it as a mouse pad now. But it actually works pretty well because it's very shiny, you know. So first of all, when I thought I could use it as a mouse pad, I didn't think that it will be working well, but I actually, you can see it's very smoothly moving, so it's working very fine. It's precisely what I wanted to see from it. Now, I was joking, actually. It's a very good book, so it's 560 pages of Spring Security there, so you might want to buy it for actually reading what's inside. This is Spring in Winter, so we are very close to the winter holidays, and I have also Rudolph here with me. And we're going to discuss today spring tips actually for the Spring developer, pro tips for the Spring developer. So tips that any professional Spring developer, Java developer, Spring developer should know. There are things that can be used not only in Spring, but they are very important for Spring, from the Spring point of view as well. So that's what we are going to discuss today. And we'll have multiple sessions each Friday for the next weeks, where we discuss plenty of important things a professional Spring developer needs to know. And I hope you learn a lot of things from myself. So I'll actually share you my screen because you'd like to see something, and I will use a presentation together with some code I will write to prove some of the things I'm discussing here with you. There are things I promise you need to take them into consideration if you are developing applications using Spring framework, it's some of them might be debatable, but from my experience I will try to explain why I consider them important and why my perspective is the way I will present it to you. So that's what we're gonna do today. Pro tips for the Spring developer, and I will start with a refresher on what Spring is, because I'd like to make sure that everyone watching this presentation will understand not only the tips themselves, but also remember what Spring is. And if you are new developers to Spring, if you, for example, are Java developers but you didn't use Spring yet, and in this case I do recommend you take a look for my Spring Quickly MIP. It's an early access for the moment. The first 4 chapters have been published up to now, but I promise you up to next summer you'll have a complete book with the shortest path a Java developer needs to take to learn the essential things to be able to work on a production application. And of course, Spring Security in Action you already see, and you can follow me on other channels like YouTube, Twitter and LinkedIn, where we can discuss, where I share other knowledge, where I have some other presentations just like this one. So do find me on other channels as well, and if you are interested, take a look on the books I wrote, because you will find them useful. So why do we use Spring? A short refresher on what Spring is. First of all, we have to remember that we use Spring to give us the out-of-the-box capabilities. Spring comes with excellent out-of-the-box capabilities, and that's why we consider it to be a fully capable application framework. It started about, say, 15 years ago, if I remember correctly, but I don't actually quite remember numbers in general. I wasn't good at history. But about 15 years ago, maybe even more, Spring was firstly released, and it very fast took the market of enterprise application development. So at that time, when I was already a developer, I was using Java E, which is now named Jakarta E, and that was the mainstream. And then very shortly, Spring became the mainstream. I'm just starting, yes. So I'm just starting, and you will have 10 tips. By the way, did I forget to tell you, I've planned 10 tips to discuss today for the pro tips of the Java developer. So I was just doing an introduction, a refresher on Spring, and then we'll take the tips one by one, which they are not necessarily in the order of importance, let's say like that. So they are not ordered anyhow. It's just a normal set, a hash set. It's unordered. Just take them as equally important, what I will tell you. So yeah, I was there a long time ago, and when Spring took the market and became the most popular framework, what I consider it to be nowadays, implementing applications in the Java ecosystem, because it provides excellent capabilities. So it's a fully capable application framework. It easily integrates with other frameworks, because you want to use some other frameworks. For example, with your application, maybe you want to connect to a database, and then you use Hibernate or any other JPA implementation. You might want to port your application from an older let's say not so flexible framework, just like as Java EE or Drop Wizard or something like that. Then Spring is very helpful, because it's very easy to implement and treat your classes as part of Spring by making use of the inversion of control container. And because of that, it's pretty easy to just make an application which doesn't use Spring to use Spring and make use of all the capabilities it offers. It has a large, active, and awesome community. So that's one of the most important things. I've told you, the things I'll teach you today are not only relevant to Spring, they are relevant in generally in programming, and some of them at least they can be used. They are basic knowledge you can use not only with Spring but with other frameworks as well, and with software development in general. And one of the very important things you need to look at when you're choosing a framework is the community itself. You need to always choose a framework that has a large, active community that helps in solving faster the issues. Sometimes vulnerabilities are found in specific frameworks. Sometimes things change fast in software development, and frameworks need to adapt. And if a framework doesn't have a community that's large and active, then you will find it more difficult to use it in your applications and keep track with everything that's going to be implemented. It's always in development. Again, that's important, because you need to use frameworks that are developed in development continuously, and they develop, and they have a community developing all the new stuff that's coming. When something is coming in the development world, then it has to be implemented by your framework as well. And I promise you, Spring will always having this active community will always implement the latest and the greatest, so you can make sure this application framework is the right choice to use in most of the cases for your implementations. And then of course it's maintained at high speed. But enough with this framework as well, because I'm sure you came mostly for the title of the presentation, which is pro tips for using Spring in your application. And I will provide you the tips one by one, and for most of them we'll always try to do some coding to show you precisely what I mean when I say, for example, tip 1, beans. Define as beans only objects that need to be defined as beans. Most of the tips that I wrapped here in our presentation are common mistakes. Not necessarily, the tips are not the mistakes. The tips are helping you avoiding the mistakes, but they are put by me in the presentation to help you avoid common mistakes that happen when implementing applications with Spring. Common mistakes I've seen a lot in the applications I'm developing, in the application I've been developing, in the applications I'm doing consultancy for, and you will reading this, keeping them in mind, you make sure you don't repeat those mistakes, and by avoiding them, you will be able to write more robust applications, more secure applications, more maintainable applications, and with all these costly effective applications in general. So that's the real purpose why I want you to see these tips, these 10 tips, and what you will gain by understanding these 10 tips I'm presenting you now. So beans, define as beans only the objects that need to be defined as beans. What do I mean by that? I will close my presentation, my slideshow now, and I'm going into my IntelliJ, and I will create a new application, so a new project. You've seen me, I've just opened my IntelliJ, but I have no project created here. It's only a test project that I have been creating just before the presentation for my own implementations. So now I will be starting by creating a new project together with you, and I will create a Spring Boot project. Spring Boot is one of the most important Spring projects of the Spring ecosystem, and you'll use it a lot. Especially today, we use Spring Boot a lot for implementing applications by making use of the convention of over-configuration principle, which means that Spring provides you out of the box a lot of configurations, and you need only to change some of them. So it's pretty cool. And one of the things, one of the mistakes I've seen in implementations, so in common applications developed out there by developers, is making beans out of objects that shouldn't be beans at all. So let's call this Spring in Winter 1.1. So this is the first meeting we have, and this is the first project. And you can use the latest version if you wish. It's version 15, but the latest long-term supported version is version 11. So I'm usually in my books using version 11, which is the latest long-term supported. But if you wish to be with the very latest version of Java, you can actually use 15, and you see that Spring Boot and Spring is compatible with the latest version. It's always a framework in development, so it's a very fast developing framework with a very fast and awesome community. And I'm gonna just add the Spring Web dependency here, which enables me the capabilities of creating Spring Web application. And I will press the finish, and I will create my project. And the first tip, remember, the first tip we've been discussing is define as beans only objects that need to be defined as beans. So in Spring, we use beans to tell Spring which are the objects we want it to manage. Because how frameworks work in general today in the Java ecosystem, and how Spring works as well, is to have a collection of objects where you add the objects you want the framework to manage, such that the framework can plug in the capabilities it comes with out of the box to those objects. So that's the purpose of the inversion of control container that we also call the Spring context. When you hear the Spring context, when you hear the Spring inversion of control container, they are more or less the same thing. You can just think of them as being a place in the memory of your application where you place the object instances that you want Spring to manage. So we have two kinds of objects in our applications. Is the objects we want Spring to manage, and is the objects we don't need Spring to manage. Not that we don't need Spring to manage. So if you don't need Spring to manage a specific object, then you don't make it a bean in the context. Why shouldn't you make it a bean in the context in this case? Because making an object a bean in the context, you add some you make your application slower by allowing Spring to actually intercept and manage that object, and you don't want to do that if there is not a real purpose for doing that. So if there is not a real purpose for making your object known by Spring, it's better to just keep it as a normal object. So remember to create, for example, a bean. You can let's say in a web application, you want to create an endpoint, isn't it? In this case, you just create a controller class. So say we create a package controllers, and inside the controllers package, then you create a class, and this class can be Happy Christmas controller. So Happy Christmas controller, it's our REST controller, and in order to be known by Spring, because when you define something in this class, you define something that you want to act as an action for a specific endpoint. That's why we call it a controller. That's why the web application, that's the web application's purpose. When you have a web application, when you define a web application, you want to have endpoints that expose pages, isn't it? So say this is a REST controller that's serving the front end of a web application. You want to write a method such as public string Merry Christmas, and this method returns Merry Christmas. And you want to add an annotation that is, say, get mapping on the method, because this will actually represent the endpoint itself, is the path and the method, the HTTP method and the HTTP path one would use to call these actions and get the result, which is Merry Christmas. But if I would start the application now, I wouldn't see anything, even though I used the proper annotation over my method to make it an endpoint. And why didn't I? What didn't I do? What did I forget to do in this case? Well, I forgot to actually add the REST controller annotation over the class. And well, this is basically making, or let's say adding, a bean in the Spring context. So this annotation wouldn't work without me in any possible way make sure that this is a bean in the Spring context, because Spring can manipulate my method here and something inside this class only if we make the object known to Spring. Well, it's a little bit more than this, because you see here we are using REST controller, which is not only a stereotype annotation. The stereotype annotation is hidden inside REST controller and is this controller, but this is a detail that you are not interested for the moment. Just take the whole idea. I make a class, I make a class, add a bean in the Spring context, like in my case here, because I want Spring to do something with that class. But if I have only a model class, and the model classes, they are usually the classes we write to model the data our application uses, like data access objects, like entities that we store in a database. These are only classes with the only purpose, with their only responsibility of modeling how the data looks like. So you don't need more than that from them. You don't need the Spring, you don't need a framework to manage them somehow. So if I have a model class and say I want a response, like a class here, my response for the Merry Christmas will be, I don't know, message, and then the message contains a string, say private string message. Then does this class need to create a bean in the Spring context? Well, looking at this class, you see it's only defining an attribute and it's only representing the way a message looks like. I can have a controller if I wish that takes the message as a parameter here, and then, for example, I can just use it here and say message, new message of Merry Christmas, my actual message. And then the way it works is that the Spring web application automatically translates this to a REST representation, to a JSON representation in my REST endpoint, of course. But the message class doesn't need anything in terms of Spring and managing it. You don't see any Spring annotation here. If you don't have any capability the class needs to benefit of from Spring, then you don't make it a bin in the context. And I often see people even creating classes that are defined as bins in the context, because you see you can actually make this message a bin in the context easily itself, either by annotating it with an annotation that represents a stereotype annotation, and in this case it will become a Spring in a bin in the Spring context. So you can do that. Or the second way, in which you create a controller's a configurations package, and inside the configuration package you have, say, a project config class, and in the project config class, which you define as a configuration class, you define a bin, say public message, and you make it a bin in the context this way, new message of Merry Christmas. And this is working now. So if I want to take this from the context in my controller by injecting it, for example, like this, using AutoWired, then you can return the message directly, which now comes from the Spring context. But let's take a look again on the implementation. You did create an instance and add it as a bin in the Spring context. But did you gain anything by just making it part of the Spring context? The answer is no. You just made the object part of the Spring context. But being that it doesn't make use of any Spring capability inside, then it's for nothing. And you just add some time and decrease the performance of your applications, of your application like this, because you now have also Spring managing your object, and instead of just creating, say, the instance you needed and then returning the message. You can test the application, it will be working. So we can just, let's start the application and use a browser to call our Christmas endpoint. Say localhost 8080/Christmas. And if my application started, oh, it didn't start yet. We have to wait a little bit because we didn't compile it yet. It's the first time it compiles. But once it started, and you see now the message here says it started, port 8080, and you can go in your browser and check that's working, and you see that we got back the message Merry Christmas, so it's actually working. But it would have worked the same if you just returned the instance instead of making it a bin in the context. And in terms of performance, it would have been better, because making an object part of the bin context without having it gaining some capabilities from Spring, it doesn't make sense. If you don't have any gain from Spring, if Spring doesn't provide any capability for that object, then the lesson is don't make it a bin in the context. Let's continue our presentation. I actually did something okay like this. I will continue like this because it seems it covers my both screens, and then I cannot see your chat anymore. So tip number 2, use constructor dependency injection. So you've seen me doing the opposite here. So you've actually seen me doing the opposite here in our application, which is I have been using on purpose the field dependency injection, because I wanted to show you that even the IDE, if it's a smart IDE, of course, it will tell you it's something wrong. So do you see that the annotation here is underlined? And if you go with the mouse over the annotation, you will see that it says the field injection is not recommended. And that's true. In general, you shouldn't use field injection. So even though I see this problem less and less in applications. I still find it here and there, and I wanted to make sure that if you are watching now my presentation, you take this into consideration, and you know that using field dependency injection is not recommended. Is not recommended because, you see, first of all, field dependency injection doesn't allow you make your fields immutable. So if I do try to use a final here and create a constructor, then it will of course force me creating a constructor, because if it is final, then it has to get a value. That's from the Java fundamentals, is not something from Spring. But then if it's final, it means it only can get a value once, which it already gets here from the constructor. So auto-wired cannot be used anymore, because auto-wired would try, say, to inject its own value as well, but it cannot do that in a final field. If you want to keep your fields final, then what you do is using auto-wiring on the constructor level. And this way, Spring knows that when calling this constructor will provide the value for the message from the context, and will automatically know to find it in its context, this message that we've been placing in the context here by using the @bin annotation. And you don't have to do anything about it, so automatically Spring will take this controller when creating it as a bin, will call this constructor and will inject the values through the constructor's parameters, and then you can do whatever you want with them. Recommended is usually only to assign them to attributes and then use them further wherever you need them in the behavior of your controller, in the methods inside your controller. And of course, to be mentioned that this auto-wired here on the constructor is also optional in case you have a version of Spring more than, I'm not sure if it was 4.3 or starting with 5. If you have only one constructor in your class, then the auto-wired annotation is optional. And that's a good thing, because as you will see later in one of the following tips, I will recommend you using a dependency named Lombok to minimize the code you are writing in your Spring application. And with Lombok, you will be able to just write an annotation to generate a specific constructor without having to explicitly write it inside the class. And because Spring doesn't expect to necessarily see the constructor and the auto-wired annotation above the constructor, then you can basically get rid of a lot of code just by using Lombok, and that's one of the next tips. But the Spring constructor dependency injection, first of all, allows you define your fields as final, which allows you making your class immutable, which is better from the maintainability point of view of your application. Remember that in Spring, the bins we create out of the box by default, they are in a scope named singleton. And this means that if we have multiple threads, which actually happens in case of a web application, then you cannot change values of the attributes, because if you try to do that, then you would get into race conditions, because you have multiple threads trying to change the same value, and that's a race condition in terms of concurrency and concurrent multi-thread applications. So that's why usually you will never see, well, you can synchronize your code, but that's not recommended either, because it could create a bottleneck in the performance and affect again the performance of the application. So the best is that when using bins, which in general are singleton, and they are anyway by default singleton, is better you make sure your methods don't change the values of the attributes. And to ensure that, and to communicate that through the code itself, then the best is to make the attributes final. That's how you communicate your intention of making a specific field immutable. And it's recommended to do that. And the only way you can do that in terms of dependency injection with Spring is using constructor dependency injection. And so many developers, especially junior developers, still do mistakes in regards to that by using field injection is because in most of the cases, examples use it because it spares you writing this constructor here. So if I want to write an example, it comes easier for me in an article or even in a book. See, if you read Spring Security in Action, you will find out that I've used in plenty of places the auto-wired on the field. And the reason I used auto-wired on the field is because I would have written a lot more code, like the constructor itself, which sometimes has maybe 3 parameters, maybe 4, and then you have to write all of them, and it takes 10 lines of code. And instead of taking 10 lines of code on the page of the book, if you imagine all the examples I have written, then I would have spared, I've spared actually a lot of pages by using auto-wired on the field. Assuming that most of the developers using reading Spring Security in Actions are at least intermediate developers already knowing what Spring is and how to work with Spring. And then I know that they wouldn't do this mistake. But auto-wired on the field, you should only use it in examples. So you will see it in articles, you will see it in books because it's a shorter syntax, but only in examples, only in proof of concepts where you know you will completely rewrite the code anyway, and only in unit tests. And when we'll discuss one of the next meetings we'll have for this Spring in Winter session, you will find me discussing about unit tests and integration tests for Spring applications, and there you will see that auto-wired on the field can be used, and it's what you will basically use with implementing your unit and integration tests, but that's another story. So that's about using constructor, and let me undo it. This is the proper way to write it. When you do injection with Spring, do it with the constructor, not on the field. And another reason for using the constructor, despite of making your application more maintainable, is again making your application easier to test. But again, because we have a dedicated meeting later on unit and integration tests with Spring, I will keep the details for that meeting. So stay tuned and follow me for the next sessions we have in the Spring in Winter series, where you'll find many of other interesting things, like for example, how does the constructor auto wiring help in terms of writing easier to test applications? Why is an application, why is a method or a class easier to test if it uses constructor dependency injection? That's what we'll discuss in one of the next sessions. And next tip that we want to discuss, tip number 3, write less code using Lombok is a good practice. I know that this is debatable, and I've seen the developers debating a lot if Lombok is good or not, but from my point of view, I managed to spare a lot of code and write the applications faster when using Lombok, so I will consider it a good practice, and I will recommend it as a tip in my Spring applications. In the latest Spring applications I've been consulting and developing, and where I could use Lombok and I used Lombok, I've spared a lot of code, writing a lot of code, and I made my applications easier to read. This is also debatable because we know with Java 15 records, a new kind of structure has been added to the Java language. It's still in preview mode, but you will have it available soon for using it in your applications. But mind that Lombok is not only getting rid of your getters and setters, as you will see in my next example. Lombok also has some other features like automatically defining only the constructor that has parameters for only the final fields. You can easily create a builder with Lombok just by adding an annotation over your class. So there are still some things that are helpful, and I know maybe records at some point will be usable, but for some other points they don't necessarily are. That's now, for example, if you think to hibernate and to using a JPA implementation, for example, using records is not an option. because in records you will find out, if you take a look on the latest features implemented for Java and you learn about records, you will see that in records the fields are default final. And if you read about Hibernate or the JPA implementations in general, you will find out that the JPA implementation is not friendly with the final fields. So, for example, for making your entities shorter, Lombok should still be a better option, and that's where, for example, records will not work in this case, because, well, you can't have JPA entities with final fields. And that's how records are working, so you cannot make them work together. So Lombok is still from my point of view a dependency that it's worth adding to your project. Let's try to add it to our project. I will create another one actually, because I would like you to compare our two classes. I will create a second project. I will copy the classes, and then I will apply Lombok for our controller, so you see what's the difference. And then you can imagine, in terms of a real world application where you have larger classes, how much more beneficial would it be to actually have a dependency as Lombok. And trust me, writing less code for your application is one of the things that make your application easier to read, easier to maintain, and spares a lot of time, and time means money. So if you care for your applications, and if you want to be profitable in terms of being a good software developer, write your applications better, easier, and faster, then writing less code is a good choice, and using Lombok is writing less code. So I do recommend for any Java developer do that. So let's create a second project, as I promised. We say spring in winter, and -1, -2, because it's the second example. But now I will also add the Spring Web dependency, which allows us create a web application by making use of the web capabilities from the Spring framework. But I will also use Lombok. And Lombok, you can find it here in the developer tools category. I will add it to my dependencies. It's basically only a dependency you need to add to your application. And in your IDE, you also need to add a plugin to use it. But once you've done that, and that's pretty fast and easy, so once you've added the plugin and you added the dependency in the POM.xml file, find here the dependency, project Lombok, then you will be able to spare a lot of lines of code. So let me actually just copy these packages all together. 1, 2, 3. I copy them, just copy them into the other application, because the functionality I want to implement is the same. So take it as being the absolutely same example. But now take a look into this 1, 2. It seems that IntelliJ didn't properly took my imports, so I have to manually change them. Oh, now it's fine. And look here now, instead of writing the constructor, so you see the constructor, I take the constructor out completely. And now, of course, my project is crying here. You see it underlined with a red line. It's because if I deleted the constructor, then there is no more dependency injection for it. Of course, you can't have a final attribute without a value. But I can now go here and just say all args constructor, and then the error disappeared, because just by adding that annotation on my class, now Lombok knows and creates automatically the constructor. Of course, I don't necessarily need to add all args constructor. I do use that because in general, all my attributes in a bin, in a singleton bin, are final. So I do use all args constructor because of that. Yeah, if you wish, for example, if you happen to have in some situations attributes that aren't final, then you can use, for example, only required arguments constructor, which will create you a constructor only for the final fields, and so on and so forth. You can create the no-args constructor as well if you would just add the no-args constructor, but be careful that Spring knows to use the dependency injection auto wiring only when you have one constructor in the class. So you shouldn't add more than one constructor. So that's why you have to decide on which is the annotation you'd like to use for your construct for your bean. But you see, I've managed to get rid of the constructor, and imagine that instead of having one attribute, I had 4 attributes. And sometimes it even happens to have more attributes. So in this case, I would have spared a lot of lines of code, and in practice, you have a lot of classes. It's not only one class. There are plenty of classes, plenty of beans you are defining in your Spring applications. And then you definitely have more attributes for class. It rarely happens that you only have one attribute. You have 2, 3 attributes, sometimes even more attributes, even though it's not recommended, but you might have more attributes. So that's how Lombok helps us and that's why tip 3, I do recommend use Lombok wherever you find it usable in your Spring applications, and it fits very well with the definition of your application. Okay, then tip number 4. So in a web app, test your logic through the controller. A unit test is not always desired. I will go faster through this one because, again, we will have a separate meeting for unit and integration tests, and I will discuss that in more detail there. But what I wanted to say is that developers usually tend to not know where to write the unit tests and where to write the integration tests, and sometimes, and I've even seen that in real world examples, they do write both the unit and the integration tests for the same thing. So I've seen cases in which developers have written a unit test for a service class, for a use case in a service class, and then that use case was called from a controller being exposed through an endpoint to a client, and then writing again the same logic to test the controller by mocking the client by using, say, mock MVC, and they've done a double job in that case. Why testing the logic through the controller and through a unit test as well? You have to be very careful because rewriting the same logic is the application of code, and not only you want to keep it short and simple as we discussed in the previous tip number 3, but you also want to avoid writing what's not necessary. That's the Yagni principle. You ain't gonna need it. And of course, avoid writing duplicated logic as much as possible, even in the test side. The test code should respect as well clean coding principle, same as you do on your implementation. It doesn't worth writing a unit test for the service if you already test the same logic through the controller. Usually when you have APIs, of course. It really depends on the type of application. So in my example here, I'm really thinking of using APIs and REST services. When you have REST services and you usually have controllers exposing use cases implemented at the service level, then what you should do is act as your client, write an integration test using, say, mock MVC for the controller, test all the logic you expect the client needs, and then you don't need to implement a unit test or unit tests or a unit test suite, just replicating the same logic again on the service side. But again, more things about that when we meet again for the discussion on testing your Spring applications in the next weeks. Tip number 5. Articles on blogs are not always the right choice for your implementation. Always read multiple sources and check the framework's reference. This is something I always teach all my students because it tends to be that I'm still seeing in projects I'm consulting and sometimes even implementing. Developers writing code that they copy paste directly from Stack Overflow, medium.com, or other important blogs that are very, very important, very useful, relevant. I'm always reading articles on several blogs. I'm using medium.com. I'm using Stack Overflow. I'm using those for a lot of things I don't know how to implement out of the box, just because I don't know everything by heart, because you can't just know software development, all of it by heart. But what you have to be very careful is that there are all old answers for questions on Stack Overflow. There are old articles written on several blogs, and software development is very, very fast changing. It's changing very fast. So that means that some implementations you find, they don't have to necessarily be the latest approach. So maybe you will find something that works and that helps you for solving your problem, but that's legacy code. Make sure what you are using is not legacy code. You might find a solution that's a workaround rather than a real solution, and that can be not because the folk writing that answer on Stack Overflow didn't know what they are doing, but maybe at that time there wasn't a way to solve that problem somehow else. So they've written a workaround, and then of course Spring and other frameworks, they are continuously changing and problems are solved, and maybe now you find a better way to solve that problem. And where do you find the latest, always the latest things, latest implementations described? In the reference. Of course, a reference is not a book. It's not something you learn from. It's something that you use when you already know at least some basics, some fundamentals, and you know how to read and how to get through it. But when you do that, so after, for example, you are learning Spring Security, and say you've read Spring Security in action. Now you know all the fundamentals of Spring Security. And I promise you know them, because if you read that 550 pages, you know all the fundamentals. Still, that doesn't mean Spring Security in action just tells you absolutely every detail of the Spring Security, because I would have had to write an encyclopedia of 2,000 pages if I wanted to do that, and it makes no sense. But knowing the default, the basics, now you can go and check the reference because you understand it and you know what to look for. And you always need to go and look for that. So mind that reading only one article is not enough. Always go and read in multiple places. Find books, find articles, read them all when you have something you don't know. Then go to the reference, read the reference as well. And only then, when you have multiple ways in which you've seen how something is implemented, take a decision on how you want to implement it and how it fits in your application, because also you have to then change it and adjust it for your application, because the applications are different, so you might do some adjustments as well. But never ever do just go search for your first example, copy paste it from Stack Overflow and use it in your Spring applications, because that way it's guaranteed that you have great chances you will make your application less performant, less secure, introduce vulnerabilities, and make it more difficult to maintain, of course. So that's really important. Tip number 6. For the Spring Data repository methods, use at query. If you've ever used Spring Data, you know that in Spring Data you can actually write only the method and access some specific, just leave Spring write the query for you, which is great. And for everyone seeing that for the first time, if you will read Spring quickly, you will see that as well, explained in chapter 10 probably will be, which I didn't write yet at this time, but I will soon write it. And you will see that in Spring Data it looks like magic working with the persistent layer, because what you do is defining an interface. You extend some interface from Spring Data. Say you use JPA and Hibernate, then you will basically extend an interface called JPA repository. You extend JPA repository and then you say just find by ID or find by product name or whatever your field is. You can even write more complex name of methods that will be automatically translated into SQL queries by Spring, which looks fine. But when you have more than one condition, like select something from table where and then condition, the longer the query becomes, the longer the name of the method becomes as well. And trust me, you don't want to have a method 250 characters long. I'm not even sure which is the limit in Java for the number of characters a name of the method might have. But you definitely don't want it to have more than 20 charts, maybe 30. I don't know which is a decent limit, but for my eyes, usually it should fit in a screen. If it doesn't fit in a screen, then it's too long. So, and not only that's long, but when it becomes longer, it starts to be very, very, very difficult to read. You will find an example in Spring Quickly about that. Somewhere in chapter 10 or 11 of Spring Quickly, you will find an example. And I will show you how a long method really looks like. And trust me, you will spare a lot of time to understand it if you really wish, but that's not the purpose. The idea is write a short name and use the @query annotation and write yourself the JPQL, which is, if you use Hibernate, if you use a JPA implementation, is that similar to SQL query language you write to instruct your JPA implementation how to work with the entities. But do use the @query annotation. Trust me, first it looks like a good option to use method names, but then you see that in real world examples they are basically more difficult to read and understand, and than queries. So when you start with JPA, you might find JPQL queries difficult to understand. Once you have a little bit of experience, you will see that JPQL is very easy to understand and read. So that's one thing. It will be easier to read with @query annotation and JPQL. Secondly, if someone refactors the name of the method, you will say, well, that's not possible because, I don't know, maybe you use integration tests. But do you really have integration tests for all your implementations? Do you really have tested everything in your application? Relying on the method name might be tricky, and in my experience, you shouldn't rely on the method name, even if it looks to be a nice feature for your Spring Data repository. Making sure you depend on a hard-written JPQL query might be, and in my experience, is a better approach. Don't forget that you have a chat there, friends. So if you want, I don't see questions. I see people joining. I say hello back as well. But if you have questions, you can leave the questions and I will answer them. So it's a live stream. Now it's your chance. If you have questions after my recording, but you will see the recording and still have questions, you can anytime find me on Twitter or on LinkedIn or even on YouTube. And you can ask me questions there as well, but now it's your chance to ask me the questions live if you have. So I will answer any of my suggestions I have here and the tips and tricks I present you. Then we go further, and this tip number 7. Be very careful what endpoints you expose with the Spring Boot Actuator. So what is the Spring Boot Actuator? For those of you who might not have used Spring Boot up to now, Spring Boot Actuator is a feature of Spring Boot that comes out of the box and is usually used to expose out of the box some endpoints that give some information about your application. What kind of information? First of all, the most important is the healthiness endpoint. The healthiness endpoint is used by the by say a separate dependency, like say the orchestration tool you use for deploying your application, or maybe the platform as a service you use. If you use Kubernetes, for example, for deploying your microservices, and your microservices are written with Spring Boot, then you will use the Actuator most probably to expose the health endpoint, which tells Kubernetes if your application is up and running, and when your application is not responding or it says it's not up and running, then Kubernetes knows to automatically restart the container. It spins down and up a container to make sure it restarts automatically your application. So we use a lot the Spring Boot Actuator now. We use it at least to integrate with your platform as a service or integration tool where you deploy your microservices written with Spring Boot. Sometimes you use it to expose more detailed information to some kind of a monitoring tool. There are a lot of monitoring tools out there which tell you about the threads inside of your application. So they instantaneously create you a thread dump. They show you the heap of your application. They can instantaneously create you a heap dump. They can tell you what beans have been registered in the context of your Spring Boot, which can be useful in some cases for debugging your application. But mind that if you expose these endpoints, if you expose them and you make them available outside, and someone can access and see the heap memory of your application, that's where you might have sensitive details. Sometimes, but I don't recommend even passwords. Be very careful with how you store the passwords. That's one of my advices you will find in starting with chapter 1 of Spring Security in Action, for example. I've seen people storing a password in a singleton. Do you know what can happen by doing that? Do you know what can happen if you store a password in a singleton in a Spring application, where somebody accessing the heap dump of your application will be able to see it? If you hashed it, then it's okay. But if you didn't hash it and you left it in plain text there, then it's a big vulnerability. You don't want that in your application. And with Spring Boot Actuator, you can actually expose the entire context of your Spring application. Imagine what happens if you expose an endpoint and you make it publicly accessible. Usually it doesn't happen because Spring Boot Actuator, especially when you deploy it, say, in a platform as a service as OpenShift or with Kubernetes, you will see in the good practice is to use a different port than for the other endpoints of your web application. You use a different port, especially because that one you don't want to map outside through your egress. But I've seen also cases in where people made mistakes. I've seen that. I've seen people exposing their full actuator publicly on production. And when someone finds out that this happens, and that you've exposed the entire context of your Spring application, or even the heap dump and the thread dump of your application, then they might make use of it to find informations about what the data your application uses that might be confidential. Of course, if you have an application that uses client data, your client might not want to expose that data outside, like name of the users, phone numbers of the users. In Europe, you have now the GDPR compliancy, which you don't want to break because there are a lot of sanctions about it. Even something as a phone number can lead to losing money. Spring Boot Actuator is a very nice tool, but make sure you take into consideration too, only expose what you really need in terms of endpoints, and never make those endpoints available outside for public calls. That's tip number 7. Tip number 8. Never store passwords private keys, and other secrets in the application properties, or say application YAML, whatever you use in your Spring Boot application files. Discussing of passwords, of course, because I was saying earlier about storing passwords in the memory of the application, and even in the app's memory is not okay to store your applications. If you store your applications, if you store your passwords in application properties as a configuration, first of all, you might tend to also subversion them if you use Git or something else, because we developers use Git today to store our source code, and in most of the cases, I'm not sure how are you working, but I'm also storing my application properties files. So if you do that, then you will not only have stored your secret data, but you'll have also versioned it, which is even worse. Secondly, be very careful with your passwords. They shouldn't be known by everyone, even if we discuss about the development and the UAT environments, not necessarily the production. Even for these environments, you might not want everyone to have all the possible access. Maybe you want some of the people have only read access to your data. And usually an application might have both write and execute access, because say you use Flyway or Liquibase to manage your database, to use version scripts for your database management, then Flyway will need a user that's able to execute those create table, alter table, delete, drop, and so on queries. Do you want all your developers in the team to have those privileges? Do you want them to be able to drop tables? You know that joke with, if you want to get up and the coffee doesn't work in the morning, just drop a table in production? Well, that might happen, and that's not a joke. That might really happen if you leave any junior developer with having access to your database. And trust me, I've really seen that. It wasn't a production table, it wasn't a production, it was a development table, but it still was really funny, because, well, it's not a happy situation, even deleting, dropping a database table in the development, because you of course then keep everyone stuck, because they cannot work, the application cannot run because it was an important table. So even for the development mode, you don't want everyone see all the credentials and give them privileges to do everything like dropping tables, especially because sometimes people might be tired, they might be just at the beginning of their learning road path, and they can do a lot of mistakes, and it's better to help them avoid the mistakes rather than allow them to do the mistakes. So help your developers avoid doing the mistakes by not giving them all the privileges on the database, even in a development environment. How you do that? Instead of writing your application, writing your passwords, secret keys, private keys in your application properties file, instead of that, you can, for example, take them from a vault, and automatically Spring Boot knows to read them, for example, from the system environment variables. And there are some other solutions as well by using different Maven plugins or Gradle plugins if you'd like. There are ways. I now can't tell you detailed how to do that, but there are ways to store your secrets in a vault or somewhere else, be managed by some kind of software capability where only some people have access, and don't spare your secrets with absolutely everyone. Tip number 9. That's a good one. No business logic in the controller and REST controller classes in web applications. I've seen again a lot of people not knowing what are the responsibilities of the layers they write in a web application. Say you write a web application with Spring. You will definitely have controllers. That's what we've been as well creating in our examples here. Yeah, you have controllers. When you have a web application, you have a controller. It's a REST controller or a controller depending on what kind of web application you write. But you have a controller. But the controller should never implement business logic. And I've seen that in production. I've seen that mistake, and I see that mistake still occurring in production applications, which is wrong. It shouldn't be. From the maintainability point of view, you should keep the responsibilities apart. And in case of the controller, the responsibility of the controller is to work directly in behind. It's called by the dispatcher servlet. In case of Spring, we have the Spring MVC and we have a dispatcher servlet, which is calling our controllers to give them the HTTP request, the HTTP response, make validations on the request and the response. That's something you can do in the controller. Be very careful what you return in a response to your client. Validate the response if it's needed. If you have exceptions, make sure you deliver in the exception body only things that are needed to be delivered, and for example avoid writing in the exception body, I know, versions, for example, IP addresses, something that can tell a specific attacker anything about the infrastructure where you deploy your application. So you still in the controller have some logic, but it's not the business logic. The logic you can have in a controller class is just validating things on the request and the response, usually. Managing the request and the response, like encoding it if that's needed somehow, decoding it if that's needed somehow. That's stuff that can stay at the controller. That's part of the controller's responsibility. But the business logic, which is the logic your application does with the data, that should always stay in a service class. That's where the use cases are implemented. The services are then called by the controller, but you keep these responsibilities apart. The logic for validating the data and making sure that what it needs goes to the control to the service to be processed in terms of business logic, that's what it stays in the controller. And in the service, you only need to have the business logic implementation. And I hope that's clear. And that was tip number 9. And the very last tip of today's presentation. That's one I really like a lot. No interfaces for the service classes. So again, I've heard that, and that's a lot of things to discuss. I like to discuss a lot on this subject. I won't do that now because it's already more than an hour since we stay here on this presentation, and I don't want to get you bored. But one of the mistakes I still see in software, in Java development in general, and of course developing Spring applications, is people still not understanding what is the purpose of the interface. That's why in Spring Quickly, the book I'm writing now, I've written in chapter 5, if I remember correctly, but it's one of the chapters there in the first part of the book, I've written a more detailed use case where I describe, hopefully well, the way interfaces are used and the purpose of the interfaces. Because in my experience, a lot of people learn how to use interfaces technically, syntactically. They know everything about interfaces in terms of the syntax, how to write the interface, that they can extend multiple interfaces, that you use the extends keyword to extend an interface from another interface, that you can implement default methods starting with Java 8, that you can implement static methods starting with Java 8 in the interfaces, that by default method in interfaces are abstract and public, so on and so forth. People know all these things, but they still don't understand what interfaces are. They don't understand that interfaces are contracts, and the reason we use interfaces is to abstract some implementations and allow a specific object only ask for what it needs without necessarily saying how that should be implemented. So because of that, because this is the purpose of an interface, a contract between two parties, object A and object B, where object A wants only to ask for something and object B is the one that somehow implements that requirement, but object A doesn't ask for the implementation. It only asks for what it needs. For this reason, you only use interfaces where you know you might have multiple implementations for the same contract, or that implementation might change in the future, so that later when it changes you can easily replace it, because having a contract you don't have to then change in all the places where you use the contract, that the contract will stay as is and then you just replace the implementation. So if you have multiple ways to implement the same thing, if you know in your application that something can be implemented in multiple ways, then you use a contract, decouple the implementations from the object. If you don't have, and know that you will never have multiple ways to implement that specific object, and that's what usually happens in terms of services. In my experience, never seen a service in a web application, a Spring application, replaced because now suddenly its responsibility can be implemented another way around. If you choose to just have a service that implements an interface just because you've read somewhere that you should use contracts, and you don't take into consideration that interfaces, aka contracts, like any other thing in software development, is something that is not some silver bullet that you use everywhere, then you will end up having service classes implementing interfaces where you'll definitely have to always add methods there as well. You will have a lot of more code because you define those interfaces and they have no use. You don't use them at all. You have now some interfaces and they are just there to be. They have no meaning in your application. Of course, it's not only for service classes. If I say it more, if I try to explain generally, I would say have interfaces and have contracts only for implementations where for the same responsibility can be implemented in multiple ways, or you expect it to change in time. If these two are not if these two do not happen, then it makes no sense to have an interface for that specific class. And usually a service class is a class where it doesn't make sense to have an interface. And I still see this anti-pattern repeating here and there in projects I'm doing consultancy for. So have in mind that and think about it and think, is that really needed? Do you really need to have interfaces for your specific object? So yeah, that was the presentation for today, and these were the 10 important tips I would like any Spring developer to know. Maybe they are not all of the things, but they are really relevant things. I took out the 10 most important, say most frequently encountered by me mistakes in projects I'm seeing and consulting, and I transformed them into these 10 tips that I've just described you, and I hope you won't do those mistakes. You might not agree with me, but take them into consideration, think about them. At some point you will find them useful, and you will see that I'm right. Thank you very much, Marina. I like them also. So me and this is Rudolf here. We'll meet again in a week from now on for a new presentation. And I hope you enjoyed my presentation for today. And these 10 tips, you will find them useful. And hope to see you soon for another meeting where we discuss more important things for the professional Spring developer. Thank you very much for being here with me. Stay tuned for the next presentations and have a great morning, afternoon, evening, wherever you are. Thanks.